Unit 1A, Lesson 2. This lesson is going to align with 7.1 in your textbook if you want some more references as you go along. So the cluster is experiment with transformations in the plane. The main standard for this lesson is going to be represent transformations in the plane using different representations, geometric software. Describe transformations as functions that take points of the plane as inputs and give other points as outputs. Okay, and then the final thing there is compare transformations that preserve distance and angle to those that do not. The first transformation we're going to discuss is a translation. This is often referred to as a slide. Every point moves in the same direction and the same distance. A few vocabulary terms: pre-image and image. The original triangle in this case, that is the pre-image. The translated triangle is going to be the image. Okay, another vocabulary term is the word prime. That is used to denote the image. So if you look at the blue triangle, when you're looking at the vertices, that's A, you see the apostrophe. That apostrophe stands for prime. So the vertice in the bottom left is actually A prime, B prime, and then C prime. So these primes labeled on the vertices, that's how we know this is the image, which means this purple triangle is our pre-image. This is the one we're starting with, A, B, C. So now if we want to look at this translation and write the rule, we start with an ordered pair, X, Y. We have this arrow denoting our translation. So let's just focus on one vertice. We have A and A prime. We want to figure out how far to the left and right, how far up and down do we have to go to get from A to A prime. So if we go in the X direction, to start at A, we have to go 1, 2, 3, 4 units to the right. So we have X plus 4. And now we want to look at the Y coordinate. We have to go 1, 2, 3, 4, 5, 6, 7, 8, 9 units down. So this will be Y minus 9. So that's our rule for this translation. The second transformation is a reflection. This is a transformation that uses a line that acts as a mirror, referred to as the line of reflection, with an image reflected in the line. So if we look at this example down here, remember the triangle on the left, that's our pre-image. The triangle on the right, that's going to be our image. We know that because of A prime, B prime, and C prime. In this case, the y-axis is going to act as the line of reflection. So if we're starting on this left side, we're reflecting across this line of reflection, the y-axis, to get A prime, B prime, C prime. It's creating a mirrored image on the other side of that line of reflection. Notice that the distance, say if we just want to look at vertex C, the distance from C to the line of reflection is 1 unit. The distance from C prime to the line of reflection is 1 unit. The distance from A to the line of reflection is 1, 2, 3, 4 units. From A prime to the line of reflection is 1, 2, 3, 4 units. So we're going to use that basic concept to help us find the new ordered pairs that are created after a reflection. The third transformation is a rotation. This is a transformation in which a figure is turned about a fixed point, called the center of rotation. So the blue triangle, that's going to be our pre-image. The red triangle is going to be our image. We know that because of the prime. We have the center of rotation. This is basically the point that we're going to pivot around to go from the pre-image to the image. So we have the center of rotation. We're going to open up 120 degrees to get to the image. Counterclockwise is actually a positive angle of rotation. If we go clockwise, that's going to be a negative angle of rotation. The fourth transformation is a dilation. This is a transformation that changes the size of the pre-image by a scale factor k. If you think about going to the eye doctor, sometimes people have to get their eyes dilated. This changes the size of the pupils. So when you think of dilation, you need to think about changing the size of the pre-image. When we're talking about the scale factor, that's going to be the number that we multiply the ordered pairs of the preimage by to get the image. If the k value is between 0 and 1, that's going to be a reduction, meaning the preimage is going to get smaller. If k is greater than 1, the scale factor is greater than 1, then that's going to be an enlargement, meaning the image is going to be larger than the preimage. So if we look at this example on the left, we have triangle ABC, the preimage, then we have triangle A prime, B prime, C prime, which is the image. In this problem, or this example, we want to determine what the scale factor is. So we can look at one of our ordered pairs, let's say A, ordered pair of 0, 2. Then if we look at A prime, 0, 4, what do we have to multiply the values of 0, 2 by to get to 0, 4? Well, if we think about how do we multiply 2 to get to 4, we have to multiply by a value of 2. So our scale factor in this case is going to be 2. K equals 2. If you look at B, if we multiply 2, negative 1, multiply each of those by 2, you would get 4, negative 2. If you multiply negative 2, each of those by 2, you're going to get negative 4, negative 4. So K is equal to 2, which is greater than 1, so this is an enlargement, which we can see to go from our preimage, we get larger for the image. A couple more vocabulary terms. We have rigid motions. Another name for rigid motions are isometries. So transformations that preserve length are rigid motions. So translations, reflections, and rotations are all rigid motions. Dilations are not rigid motions because they do not preserve lengths. So the first three, when we did translations, reflections, and rotations, those did not change the size from the preimage to the image. All they did was change the position of the original shape. Dilations change the size of the preimage, so that's why those are not rigid motions, they're not isometries. Here are a few basic rules for how reflections, rotations, and translations are going to affect the ordered pairs of the preimage to get the ordered pair of the image. Okay. For the sake of simplicity, for all of these, we're going to assume that our shapes are centered at the origin. Okay, we can have reflections, rotations that are not centered at the origin. That gets a little more confusing. So to start out, we're just going to assume everything is centered around the origin. This might be something you want to put in your notes. So in this example, triangle A prime, B prime, C prime is a translation of triangle ABC. We want to determine what the rule is. So all we really have to do is focus on one vertice, for instance A to A prime, determine how far we're moving horizontally and vertically. So if we're looking at A, we need to go 1, 2, 3, 4, 5, 6, 7, 8, 9 units to the right. So this is x plus 9. And then we need to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units up. So it would be y plus 10. So that's our rule for this translation. In this example, we want to write the coordinates of the vertices after a reflection across the x-axis. So since this is a reflection across the x-axis, I know the x values of the ordered pairs of the preimage are not going to change. The only thing that's going to change in this case are the y values. So that's why I already have the x values filled in for all the ordered pairs of C prime, D prime, E prime, and F prime. So if we're looking at C, and we know we're reflecting across the x-axis, that's our line of reflection. We are 1, 2, 3, 4, 5, negative 6 units down. So if we're reflecting across the x-axis, that means our y value is going to be 6 units up. So this is going to be positive 6, which means D is going to be a positive 6 as well. E prime is going to be, E is negative 2, so E prime will be positive 2. And then F prime is going to be positive 2 as well. And if we wanted to plot these quick, negative 3, 6, 1, 2, 3, 4, 5, 6, 3, 6, 3, 2, and negative 3, 2. After a reflection across, well, that's not very good. After a reflection across the x-axis, this would be our image. Write the coordinates of the vertices after a rotation 180 degrees counterclockwise around the origin. Since this is a rotation 180 degrees around the origin, it doesn't matter if it's counterclockwise or clockwise, you're going to end up in the same position. Okay, so that part's irrelevant. If you remember the rules you wrote down in your notes, or should have written down, if there's a 180 degree rotation about the origin, all you have to do is change the signs on the x and y ordered pair. So if we're looking at C, this ordered pair is 2, 2, so C prime is going to be negative 2, negative 2. D prime is going to be negative 10, negative 2. E prime is going to be negative 10, negative 8. And F prime is going to be negative 2, negative 8. So all you have to do, if it's 180 degrees around the origin, change the sign on both the x and y coordinates. So I plotted those points quick. This looks a little better than the last rectangle I tried to construct. We have C prime, D prime, E prime, and F prime. Remember, if we're rotating counterclockwise, well, that should be 180 degrees, not 120. 180 degrees counterclockwise is actually a positive value. So now you can see how that rotation about the origin works. In this last example, the orange shape is a dilation of the black shape. What is the scale factor of the dilation? So if the orange shape is a dilation of the black shape, that means the black shape is the pre-image, the orange shape is the image. So we could see this is a reduction. Okay, our image is smaller than the pre-image. If it's a reduction, remember, our scale factor has to be between 0 and 1. So if we just look at this bottom part, and look, we have a distance 1, 2, 3, 4, 5 units for the pre-image, and a distance of 1 unit for the image. So we need to determine what do we have to multiply by 5 to get a value of 1. Using a little logic, we should be able to determine that we would have to multiply by 1/5. If you take 5 times 1/5, the reciprocal, you're going to get a value of 1. So the scale factor in this case is 1/5. That is between 0 and 1. This is a reduction, which makes sense because the image is smaller than the pre-image. Okay, so that wraps up this lesson. We had 4 different types of transformations. We had translations, reflections, rotations, and dilations. The first 3, translations, reflections, and rotations, those are all isometries, rigid motions, because they preserve lengths. They do not change the size of the pre-image. All they do is change the position. So a dilation is different than the other 3 because it changes the size of the pre-image.